Hello friends, welcome back. So today we are going to discuss an important concept in finance, which is called the duration of bonds. This concept of duration is very important in security analysis and portfolio management part of the finance. So we'll try to understand this concept, which is seemingly tricky, but is super easy, as will come out from these four problems that we are going to solve here, right? So we will begin with this problem number one, which is going to give us an idea of Macaulay's duration, right? So here the problem statement is like this, that we have been given a bond which is having a par value of $100. This is the discount rate, 12%. It's paying annual coupon of 8%. That means annually this bond is going to give us 8 rupees every year till its maturity, which is 3 years. And we have to find Macaulay's duration. So obviously this bond is going to mature in 3 years, right? But then there is a duration which is different from this given maturity duration, right? So this is what this we are going to understand in this uh, in this problem, right? So here is the solution of the problem, right? So let's go ahead. So what we find here is that first of all, it's good to understand what is the price you would like to pay for this bond. So price today that you would like to pay for this bond is the present value of all cash flows. So first of the cash flows is the dividend of $8 for 3 years, and then you get 100 at the end of 3 years. So you sum up both the cash flows, the present value of the cash flows, and this is the price that you are going to pay today for this particular bond. We can further explain how we arrived at this present value of the cash flow. So if you see that there are three dividends, one, two, and the last one is coming along with the terminal value, which is $100, right? So you discount each of them with the 12% rate of interest, and this is your present value interest factor, and finally what you get is these are the three present value of the cash flows, and when you sum them up you get the fair value which any investor would like to pay for this uh, bond today. Fine. Okay, so this is step one, that you get the fair value of the bond today. Now what's exactly happening here is not difficult to understand. See, this bond is paying some amount every year in addition to its terminal amount. What does this mean? This $8 you are getting at the end of year one, another $8 you are getting at the end of year one, another $8 you are getting along with the terminal value, right? So what happens if this bond is not paying? For example, if this bond is not paying this $8 here, $8 here, $8 here, that means this bond is a zero coupon bond then, and all the money is coming at the end of 3 years only. Now compare that zero coupon bond situation with the situation here. So what you find here is that some money is actually flowing in before the terminal value, before 3 years. So what does this mean? Your cash flows are are tricking in even before your bond has matured. And we all know that the value of money that we have today is always more than it is tomorrow. For example, let us assume that the discount rate is 100%. What does this mean? If I have $1,000 today with me, that $1,000 will become $2,000 tomorrow, right? So if I give you an offer that do you want $1,000 today or $2,000 tomorrow, both are same things, because the market discount rate, it's hypothetical example, market discount rate is same 100%. But then still most of you will prefer to have $1,000 today rather than $2,000 tomorrow. Why? Because everything else equal, the value of consumption today is more than the value of consumption tomorrow. So this cash flow which comes in before the terminal value makes the brings in the concepts of duration. That means this end of 3 year that we talk about here, end of 3 year, right? So this means that if a bond is paying some coupons every year, then I am little bit more happy than having a zero coupon bond. And thus the effective duration, the actual duration with which you can compare equally uh, 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 equal feature bonds, is going to be different than 3 years, right? So you have to have weights assigned for the cash flows in between. So this is a 3 year coupon bond. So what we have here is the year 1 weight, year 2 weight, year 3 weight. And how do you find these weights? So these cash flows present value you have with you. So each of these cash flows present value, you just divide by the by the the fair value that you arrive at. And this gives you 3 weights: weight for year 1, weight for year 2, and weight for year 3. Now, how do you find Macaulay's duration? If you have found out the weight in step 2, the step 3 is pretty simple. You can simply deploy this particular formula that you multiply each of the weight by the time. So the weight 1, this is the weight 1, you multiply it by 1 here. This is weight 2, you multiply it by 2 here. This is weight 3, you multiply it by 3 here. You sum it up, and lo and behold, your duration, the Macaulay duration, is with you. How much is it? 2.77 years, which is less than the duration, which is the 3 years, which is the maturity period of the bond, right? So for a coupon paying bond, what does it mean? Since the cash flows are occurring before 3 years, every year I'm getting $8. So my duration, the Macaulay duration, is less than my maturity period. And that makes me happy, right? So this bond is having a Macaulay duration of 2.77 years. So what does this mean intuitively? This means that for a small change, say 1% in the market discount rate or the YTM, the bond price can experience a change of 2.77%, which was a Macaulay duration, right? What does this mean in other words is that the YTM elasticity of the price, I repeat, YTM elasticity of the price of the bond can be given by Macaulay duration. So if you have found out the Macaulay duration, that can be your elasticity, the YTM elasticity of the price of the bond, right? And how do you define elasticity, which is a function of this duration? It is percentage change in price divided by the percentage change in 1 plus YTM. So the formal formula is over here in green. So percentage change in price is equal to minus of elasticity, which we found out from duration. This elasticity is nothing but Macaulay's duration, say, and multiplied by change in YTM divided by 1 plus YTM, right? This simple formula is going to be used in the next problem. That's further going to make us understand the concept of elasticity, right? So the next problem says that for a zero coupon bond having a price of $1,000, maturity is say 10 years, right? And how much this price elasticity will be there? That means how much price is going to change if YTM goes up by 1%, right? So if YTM today is 8%, it goes to 9%. Soon after, you bought the bond and it stays same to 9%, then you are going to have how much price change will be there. And we all know that since the bond theorem says that the YTM goes up, price goes down. So price will obviously go down, but how much will it go down? So let us deploy the Macaulay duration concept here. And this much is clear to you, I believe. It's pretty simple. The change in YTM is 0.01. You plug in that formula, and you get the percentage change in price, which is equal to negative because the yield has gone up, so the price has to go down, that's why negative. D, this is duration. So suppose duration given here is a maturity of the bond 10 multiplied by 0.01 divided by 1 plus YTM, the original YTM, the 8% one, right? So what you arrive at is 9.25%, right? So you can predict a 9.25% decline in this bond's market price if the yield goes up right in the first year, say to 9%, and it stays 9%. So this is important here. It has to stay at 9%, right? So this elasticity concept is explained by this particular problem. Now let us move ahead, do another problem, and try to understand uh, this concept of duration again, so that it becomes consolidated. So here the problem is pretty simple. We have been given a coupon rate, a market discount rate, or the YTM, a maturity period, and we have to find the Macaulay's duration, right? So if we make a table like this, this is year 1, year 2, year 3, and the cash flows are $8, $8, and $8, and we get a terminal value of 100 also. So we got the present value of the cash flows like this, right? And when we sum it up, you get the present value like this. But when you multiply with the weights, for example, you multiply 1 with 6.97, you get this. When you multiply 2 with 6.05, you get this. When you multiply 3 with 71.1, you get this. And when you sum it up, what you get is the weighted cash flow, weighted value of the all cash flows in present. So you can see there's clear difference. So when you give weights to the cash flows coming in every year, obviously your present value becomes higher. And now what is your Macaulay's duration? Simple. You just divide the 232.09 with 84.021, and you get the Macaulay's duration, 2.76 years, right? So this second example in which we found Macaulay's duration, hope it's clear. Let me explain that little bit once more. So here you have the problem statement. Yeah, that a bond is having a YTM of 15%. Then you have to find the Macaulay's duration for this particular problem, and Macaulay's duration is found out by creating a weighted PV cash flow column in the table, right? And which gives you 232 as against 84.021, which is the usual way of calculating present value of the cash flow. And when you divide the two, you arrive at the Macaulay's duration, which is 2.76 years. In other words, what does it mean? It means that every 1% change in the YTM of this particular bond is going to give me 2.76% change in the price of the bond, right? And you can see that since it's a coupon paying bond, the Macaulay duration is less than the maturity period of the bond, right? And in the last problem, we are going to understand the concept of uh, uh, the modified duration. We are going to understand the limitation of Macaulay's duration, something related to the concept of convexity, which we will discuss in some another video. But for here, you can understand that why Macaulay duration is not really a great idea. It's certainly better than the maturity period, but then there is certain limitation which we are going to understand here, and this also is going to make us understand the concept of modified duration. So the problem statement here is in question 1. You remember question 1? Let me go back to question 1. So this was our question 1 that we solved. So there was this bond with a face value of 100, YTM 12, coupon 8, paid annually, maturity 3, and we found the Macaulay duration, summing up the weights, and which was 2.77. So this was our problem 1. So for this particular problem, suppose YTM, which was earlier, say, which was uh, earlier, 12%, 12% YTM. This 12% YTM now changes to how much? 13%, just 1% change, because Macaulay duration is valid for only small changes. So it changes to 13%. So does Macaulay duration predict, a good measure of price change? So this is what we are going to solve here. So when the YTM becomes 13%, price will become the present value of cash flows for the 3 years, which is pretty simple to find. The first coupon payment divide by the discount rate, second coupon payment divide by the square of the discount rate, third terminal plus coupon payment discounted at 13% for 3 years, and all this gives you what is a fair value today of this particular bond. Fine. So what is you plug in the elasticity formula on, you just simply calculate the percentage change in price, because this is what the market is going to pay for this change, for this 13% YTM. So 13% YTM, market is going to pay this, and we found that for 12% YTM, market was paying this much price. So price has fallen down, and how much in percentage terms? This fall is 2.42%. The new price minus the old price divided by the old price, right? So this is what you get, the percentage change in price, this one out here. Okay. So what Macaulay's duration will predict out here? So Macaulay's duration, we calculated in the question number 1. We found that Macaulay duration was 2.77, right? So Macaulay duration was predicting a price change of 2.77%. You understand? So Macaulay duration was saying that this price will fall by 2.77%, but market actually, decided that this is going to fall by 2.42% only. Hence, this Macaulay's duration is actually giving us more decline than what actually would have happened. So the better measure of the price change, instead of this Macaulay duration, will be modified duration. So MOD, the modified duration, is arrived by this formula. You divide the Macaulay duration by 1 plus YTM, and you get a value 2.47, which you see is closer to 2.42, right? So modified duration is closer to the reality, in the sense that it predicts better, you know price finally. So let me sum up. How did we understand about the duration of the bonds, and Macaulay duration and the modified duration? In problem 1, we tried to find out the Macaulay duration for a bond with 12% YTM and 8% coupon maturing 3. We found the Macaulay duration was 2.77 years, right? Then we tried to elaborate that what does it mean intuitively. We brought in the concept of elasticity here, and this formula is quite important about elasticity in the green, right? And which we used in the next formula for a zero coupon bond, say having maturity of 10 years, and we could predict the price change of 9.25%. It's actually 9.25% decline. There's a minus out here. This is negative 9.25. So in the next problem, we try to consolidate our concept by finding out the weighted present cash flow, and then divided it by the uh, normal PV of the cash flow, and we got the Macaulay's duration, right? And then we tried to see whether Macaulay's duration is a good enough predictor of price change when the YTM changes by 1%. We found that Macaulay's duration is little giving lesser price than what actually should have been, and so you use this formula of modified duration and arrive at the better measure of price change, or the elasticity, right? Thank you so much. We'll share more such videos. Thank you.